Bright Tuty. Every student matters.
Hello friends, in earlier videos we learnt all the properties which we have related to integers, whole numbers, rational numbers. Now we'll go ahead with the exercise, very first exercise, which is exercise 1.1. We did few examples as well on the basis of all the subtopics which we learnt in the earlier videos. Now starting off with first exercise, the very first question is here. Now using appropriate properties, we need to find this. Now we've discussed in earlier video that how do we go about it. So the first thing that you're going to see is, can we see anything, any of the rational number which is coming twice or which is occurring twice? If we'll have a look, we can see that yes, 3 by 5 is a rational number which is coming twice. So what do? We will take them as a pair and we'll shift it to another side, like we will be getting minus 2 by 3 times 3 by 5 minus 3 by 5 times 1 by 6 plus 5 by 2. So by commutativity, we shifted to the side which is closer to 2 by 3 times 3 by 5. Now the next step will be, out of these two, we can take 3 by 5 common. So after taking 3 by 5 common, we will be left with minus 2 over 3 minus of 1 over 6, and we did it by using associativity, wherein we know that A times B minus A times C will be taking A common and in brackets will be left with B minus C. So now over here that will be 3 by 5. We have 3 and 6, so we'll take an LCM as 6. So we are left with minus 4 minus 1 plus 5 by 2. So 3 by 5 times minus 4 minus 1 is minus 5 times minus 5 by 6 plus 5 by 2. So let me just change the color. Now we can cancel this 5 out. We can cancel 3 and there will be 2. So we are left with minus 1 over 2 plus 5 over 2. So taking 2 in the denominator, we are left with minus 1 plus 5, which is 4 over 2, which is 2. So the final answer which we will get by using appropriate properties, so very first part of this exercise is 2. Now let's try and move on to second part. We'll follow the same procedure, give it a look, check it out that which of the rational number is coming or occurring twice. Now if we'll have a look, we can see that 2 by 5 is a rational number which is coming twice. So we'll be doing the same thing, we'll be shifting this to this side. So we'll be writing 2 by 5 times minus 3 by 7 plus 2 by 5 times 1 by 14 minus 1 by 6 into 3 by 2, which is already there. Now over here we have used commutativity. We need to write that reason, that why did we do that. Now out of these two we'll take 2 by 5 common. So we are left with minus 3 by 7 plus 1 by 14 minus 1 by 6 into 3 by 2, and we can write it as associativity, which we used over here. Now minus 3 by 7 plus 1 by 14, we'll be taking LCM and we'll be getting 14. 14 divided by 7 is 2, minus 3 times 2 is minus 6 plus 1 minus 1 by 6 into 3 by 2. Now if we change this color, we can cancel this out and we'll be getting 2. Now we are left with 2 upon 5 times 1 minus 6 is minus 5 upon 14 minus 1 upon 4. Now we can cancel this out, 5 and 2, 7. So we'll be getting minus 1 by 7 minus 1 by 4. So we'll be taking LCM, we'll be getting 28. So we're getting minus 4 minus 7, which will be minus 11 upon 28. So by using appropriate properties, the final answer we should be getting is minus 11 upon 28. Now let's move on to the second question now. Question 2. Now it says that we need to write the additive inverse of each of the following given below. Now the first one is 2 over 8. That means 2 upon 8. We need to write additive inverse of this. Now to find out additive inverse, what do we actually do? Additive inverse of 2 by 8 will be minus 2 by 8. How come? Because after adding these two, we'll be getting the final answer as 0. So Minus 2 by 8 is the additive inverse of the given rational number. Again, minus 5 by 9, the additive inverse, we can write it like this, the additive inverse of minus 5 by 9 is 5 by 9, since minus 5 by 9 plus 5 by 9 is equals to 0. Let's move on to the next one, minus 6 upon minus 5. So we'll just cancel it out whatever we could. So we can cancel minuses out. So we're left with only 6 by 5. Now the additive inverse of 6 by 5 will be minus 6 by 5, as 6 by 5 minus 6 by 5 equals to 0. Now let's move on to 2 upon minus 9, or we can say minus 2 upon 9. So what will be the additive inverse? Yes, you're right. So the additive inverse of minus 2 by 9 is 2 by 9, and we know the reason, that 2 by 9 and minus 2 by 9 will be equals to 0. Last but not the least, we can write it down in the same way, will be 19 minus 19 by 6, and we can write it down that the additive inverse of minus 19 by 6 is 19 by 6, as minus 19 by 6 plus 19 by 6 will be 0. So additive inverse is basically, we will be adding the same number, but if we have minus, that will be plus, if we have plus, that will be minus. So this is how we go with additive inverse. Now let's move on to another question. Herein we need to verify that minus of minus x equals to x for these two rational numbers, as we started off with, and we've solved few examples on the basis of this only. So we'll start off by writing it down, that the additive inverse of x is minus x, which is equals to minus 11 by 15, since 11 by 15 minus 11 by 15 equals to 0. Now the same equality holds true, and the equality holds true for the additive inverse of the same inequality holds true for minus of minus x, that is minus of minus 11 by 15, which will be 11 by 15. So the same equality holds true for this as well. So the same equality says that the additive inverse of minus 11 by 15 is 11 by 15, as minus of minus x will be this, and we know that the equality is the same which we discussed here. Now let's move on to the second part, and we do the same way which we did part 1. Now let's start with second part. We can write it down, the additive inverse of x, which is minus 13 by 17, is minus x, which is 13 by 17, as 13 by 17 minus 13 by 17 would be equals to 0. Now the same equality shows the additive inverse of 13 by 17 is minus 13 by 17, which means minus of minus x, which will be x, as minus of minus 13 by 17. Since we have x as minus 13 by 17, so we can write it down this way. So minus of minus x, if x is minus 13 by 17, minus x will be 13 by 17. So if we'll take minus out in there, we'll be getting minus 13 by 17, which is equals to x only. So the same equality shows that the additive inverse of minus 13 by 17 is 13 by 17. Then 13 by 17, additive inverse of 13 by 17 is again minus 13 by 17, which is actually the value of x which we started with. Now let's move on to another question. Over here we need to find multiplicative inverse of the following. Additive inverses, we need to add that number. If we add both of them, we'll get 0. Now multiplicative inverses, whatever number which we are looking for, if we multiply with the question or the number which we already have, it gives us 1, then only we can say that it is the multiplicative inverse. So if I am talking about multiplicative inverse, the only thing which we need to keep that in mind, we need to start with reciprocal of it. That's it. Now, additive inverses, we'll just drop that minus sign. If it's there, we'll drop it. If it's not there, we'll add it. This is additive inverse. But if I'm talking about multiplicative inverse, it's generally the reciprocal of the number which we already have. So if we have minus 13, so the reciprocal or the multiplicative inverse will be minus 1 by 13, as minus 13 and minus 1 by 13 is equals to 1. So we'll write it this way: the multiplicative inverse of minus 13 by 19 is minus 19 by 13, as, or since, minus 13 by 19 upon minus 19 by 13 equals to 1. Let's move on to another part. I hope you can do it yourself. Give it a try. I hope it will not take more than few seconds for you to give an answer. So the multiplicative inverse of 1 by 5 is 5, since 1 by 5 times 5 equals to 1. Last but not the least is, we'll multiply and solve this first, and then we'll move on to the final answer. So the final answer, the number will be 15 upon 56. So now we can say that the multiplicative inverse of 15 over 56 is 56 upon 15, since 15 upon 56 times 56 upon 15 will be equals to 1. So additive inverse, we'll just dropping and adding the negative sign or minus sign, and multiplicative inverse, we'll just do the reciprocal of the number which we already have. Now let's move on to other parts which we are left with. Again, we'll be solving this first, so we'll be getting 2 by 5. Now the multiplicative inverse of 2 by 5 2, as 2 by 5 times 5 by 2 equals to 1. Let's move on to the last part. So the multiplicative inverse of minus 1 is minus 1 only, as minus 1 times minus 1 equals to 1. So if you can see, minus 1 and 1, the multiplicative inverse of these two numbers is exactly same, because once we multiply it with the same number, we'll be getting 1. So maybe fill in the blanks. We can say that, tell me two numbers whose multiplicative inverse is the number itself. So there could be some other questions as well. Once we'll just come on to that question, maybe we'll discuss that question too. Now let's move on to another question. Another question says that, name the property under multiplication used in each of the following. So let's start with the very first part. Minus 4 by 5 into 1 equals to 1 into minus 4 by 5 equals to minus 4 by 5. So ultimately what we did is, 1 is the multiplicative identity, because this shows this thing only, that 1, since we are multiplying it by 1 and we are interchanging the numbers, then only we are getting, then also we are getting the same answer, which is minus 4 by 5. So this shows that 1 is the multiplicative identity, which is the property used under multiplication. Now let's move on to the second part. Now you can simply see that we have just interchanged the numbers or the rational numbers. So what property which we used is commutativity. We've discussed it as well. So it is commutative property or commutativity. Now let's move on to the minus 19 by 29 into 29 by minus 19 equals to 1. So what we can say, it shows that it is the multiplicative inverse, or maybe we can say reciprocal. Now we'll be moving to another question, which is question 6. Now we need to multiply 6 by 13 by the reciprocal of minus 7 by 16. So we'll be writing with the very first thing that reciprocal of minus 7 by 16 is minus 16 by 7. So what do we need to do? We need to multiply 6 by 13 with the reciprocal of it. So can we cancel anything out? No, we can't. So we'll be multiplying this. So we'll be getting minus 96 over 91. So 6 times 16 is 96. 13 times 7 will be 91. So this will be the final answer for question 6. Now we'll be moving on to question 7. We need to tell that what property allows you to compute this. So what we actually did, first of all, we have 3 rational numbers. So if I'm talking about 3 rational numbers, that is specially which we discussed is associativity. Now in associativity, what is the other thing which we have? 1 by 3 times we have taken this pair first, and the second time we have taken pair of first 2 numbers. So we can straight away say that this is associative property which allows us to compute this as the number which is given over here. So moving on to another question. So question 8 says, now is 8 by 9 the multiplicative inverse of minus 1 by 8? Why or why not? So first of all, let's just check that minus 1 by 8 is what? So how do we convert this mixed fraction to improper fraction? Multiplying these two, and whatever comes we'll add it. So there will be minus sign as it is. So 8 times 1, 8 plus 1 is 9. So we'll be getting minus 9 by 8. So it asks that is 8 by 9 the multiplicative inverse of minus 1 by 8? We'll be saying no. Why? Because if we are multiplying these two numbers and after cancelling them out as well, we are getting minus 1, not 1. So we'll be writing no because the product is not 1. We can say that it is a multiplicative inverse only if we can multiply these two and we'll get the final answer as 1. So this is how we do if we ask the question like, is this the multiplicative inverse or is this additive inverse of another number which is given. Now let's move on to another question. Now it says that is 0.3 the multiplicative inverse of 3 1 by 3. So if I'll just convert 3 1 by 3 to improper fraction, we'll be getting 3 times 3 9 plus 1 10 by 3. Now if we have 10 by 3 and we need to check that is 0.3 the multiplicative inverse of 10 by 3. To 0.3 we can write it down as 3 by 10. So we can say yes, 0.3 is the multiplicative inverse of 3 1 by 3. Why? As 10 by 3 and 3 by 10, these two numbers, we can just check that out, we can cancel them out, we will be getting the product as 1. So if you are getting the product of two numbers as 1, we can say that 1 is the multiplicative inverse of the other rational number. So this is question 9, which is the answer of it. Now let's move on to question 10. We need to write the rational number that does not have a reciprocal. So we need to write a rational number which does not have a reciprocal. So if I guess in my mind can be 0, 1, minus 1, but 1 and minus 1 still have the reciprocal, but 0 is the only rational number which does not have its reciprocal. We discussed it in earlier videos as well. Once you go through that video, you will be able to understand why. Let me just tell you here as well, because to 0 we can write 0 by 1, and if I will be talking about reciprocal, that will be 1 upon 0, and if in denominator we got 0, we can say that it is not defined. So we can say that 0 is the only rational number that does not have a reciprocal. Now I will give you a few seconds, try to answer second and third part. Now second part says the rational numbers that are equal to their reciprocals. So you need to write down the rational numbers. It can be 1 or 2 that are equal to the reciprocal. So whatever the number is, that will be equal to the reciprocals. We need to find that two numbers. I can say that it is a good guess because in few seconds back we did the same thing, that you can get these questions in some other forms as well. So 1 and minus 1 are two numbers that are equal to the reciprocals, because the reciprocal of 1 will be 1 and the reciprocal of minus 1 will be minus 1 only. Let's move on to the third part. Now the rational number that is equal to its negative. So a rational number which will be equal to its negative. So it can be 1 that will be equal to its negative. Would be minus 1. No, that's not correct. Minus 1, 1. Yes, good try. Very good. 0 is the only number, the rational number that is equal to its negative, because the negative of 0 will be negative 0, which is itself a 0. So the rational number that is equal to its negative is 0. So the first is 0 is the only number, rational number that does not have a reciprocal and that is equal to its negative. And 1 and minus 1 are the rational numbers that are equal to their reciprocals. Now let's move on to the final and the last question of this exercise, and then in the next video we'll be moving on to some other subtopics which we have. So let's start with the first one. Fill in the blanks. 0 has dash reciprocal. So you need to fill it accordingly. So I'll give you a few seconds, think and answer. 0 has no reciprocal. So we don't have any reciprocal for 0, which we discussed in earlier question as well. Now the numbers dash and dash are their own reciprocals. Yes, very good. 1 and minus 1 are the numbers which are equal to their own reciprocals. Now the reciprocal of minus 5 is minus 1 by 5. So we'll be just doing opposite of it. So minus 5 by 1 will be minus 1 by 5. Now reciprocal of 1 by x, where x is not equals to 0, is x. So we'll just doing a reciprocal of 1 by x will be equals to x. Now the product of two rational numbers is always can be an integer or something, but yes, the product of two rational numbers is always a rational number. You can take any two numbers, any two rational numbers, multiply them, take out their product, you will always be getting a rational number as your final answer. Now last but not the least is the reciprocal of a positive rational number. Let's say if we have 1 by 5, the reciprocal will be 5. So that means this will always be positive. So the reciprocal of a negative rational number will always be negative. So maybe they can ask that the reciprocal of a negative rational number is, then we'll write negative. So it depends what they ask, we can need to answer it accordingly. So we are done with our first exercise.